Welcome. Look, if you're tuning into this explainer right now, chances are you are physically uncomfortable. There is literally nothing quite as stressful or as bone-chilling as waking up on a freezing morning, hearing your furnace kick on, and then feeling a blast of icy air coming from your vents. It's miserable, it's super stressful, and quite frankly, it can make you panic about some massive repair bill. But hey, take a deep breath, grab a blanket, and let's get you warmed up. Today, we're going to break down exactly what's happening and guide you through a really clear, practical approach to fixing it. It's like the ultimate betrayal by your home appliances, right? You ask for heat, and your system responds by acting exactly like an air conditioner. No way. You might be standing over your floor register right now, completely bewildered by this. But I promise you, your system hasn't gone crazy. There is a very logical, step-by-step, mechanical reason for this, and by the end of our time today, you're going to understand exactly how to troubleshoot it. So, here's our game plan for today. We'll start with the cold air mystery, then look at simple settings, move on to an airflow check, dive into the ignition sequence, and finally cover when to call pros. Basically, what we're doing here is starting with the incredibly simple, entirely free fixes you can do right now, and then working our way up the ladder to the more complex mechanical failures. All right, section 1, the cold air mystery. Let's demystify what's actually going on in there. First things first, your furnace is not maliciously freezing your house. It just feels that way. From an engineering standpoint, only one of two things is occurring here. Either the system is experiencing a failure that prevents it from generating heat, or the system is actually perfectly fine, but it's just being told to circulate the ambient, already cool air around your home. Just understanding that it might just be moving room temperature air makes the whole situation feel a lot less like a crisis and more like a solvable puzzle. Moving right along to step 1, simple settings. These are those classic facepalm fixes. Now, what's really interesting about this slide is how often an expensive service call comes down to just one tiny switch. Look at the incorrect setting on the right, leaving the fan set to on. When your fan is set to on, it runs continuously, 24/7, regardless of whether the furnace is actively heating the air at that moment. So when the heating cycle finishes, the fan just keeps blowing the ambient air around. And because moving air creates a wind chill effect on your skin, it feels like the furnace is actively blowing cold air. You absolutely want your fan set to auto, so it only blows air when the heat is actually running. Okay, if your thermostat settings are correct, it's time for step 2, the airflow check. This is incredibly common. A clogged, dusty, or discolored filter heavily restricts the amount of air your furnace can breathe in. It's like trying to run a marathon while breathing through a straw. If the furnace can't pull in enough air, the internal components overheat very quickly. Now, modern systems are really smart. They realize they're overheating, and they immediately trigger a safety protection switch that shuts the burners down. However, the blower fan might actually keep running to cool the system off, resulting in, you guessed it, cold air from your vents. So the furnace is actually shutting itself down to protect your home. Simply replacing a dirty filter might instantly restore your heat after the system resets. Okay, let's dive into this next part, the third step, which is the ignition sequence. This is where we get into the more mechanical side of how a furnace creates heat. Think of this precise ignition sequence as a relay race. First, the inducer fan turns on to clear out exhaust gases. It passes the baton to the hot surface igniter, which starts glowing red hot. That passes the baton to the gas valve, which opens up to release fuel. And finally, the burner flame ignites. If any single runner in this relay race drops the baton, say the igniter isn't heating up or the gas valve gets stuck, the entire sequence fails. When that happens, the system will often default to blowing cool air while it waits, retries, or eventually locks itself out completely. You might actually hear this term thrown around by professionals, short cycling. This is common HVAC jargon for a system that starts up, tries to complete that relay race we just talked about, but fails and abruptly shuts down. If you're hearing unusual, repeated clicking noises coming from your basement, or you're noticing that your system runs for maybe 2 minutes and then just shuts off without warming the house, yep, you're experiencing short cycling. Now, the flame sensor brilliantly illustrates just how sensitive these systems really are. It's this tiny little rod that sits right in front of the burner. Its entire job is just to detect fire. If the gas valve opens but the sensor doesn't feel a flame, it shuts everything down in fractions of a second to prevent raw gas from filling up your home. But here's the catch. If that tiny sensor gets covered in even a microscopic layer of carbon or dirt, it literally goes blind. It can't feel the flame that's actually right there, so it tricks the whole system into halting combustion. Let's see how all of this builds into the final phase of DIY troubleshooting. If your blower fan is running but you have absolutely no heat, your system's control board has likely gone into a safety lockout state. I really want to reiterate the safety framing here. Your control board is actively preventing ignition on purpose. It's doing this to keep your household safe from what it perceives as blocked vents, bad exhaust, or repeated failed ignitions. In fact, many modern units will even flash a blinking LED light on the control board, which is an error code, to tell you exactly why it locked you out in the first place.
And that brings us to Section 5, when to call the pros. This is where we step back from the DIY fixes.
Look, if you've checked your thermostat, you've replaced your filter, and your system is still blowing cold air, it's time to stop tinkering. And more importantly, if you ever experience any of these specific danger signs, especially smelling natural gas, seeing black soot build up around the unit, or witnessing repeated violent ignition failures, you need to call an HVAC professional immediately. Seriously, do not try to bypass safety switches or force the system to run. So the crucial point is that a professional technician has the actual tools and the specialized training to safely evaluate these systems. They don't just guess, they test the precise electrical draw of the sensors, they check the exact pressure of the gas valve operation, and they inspect the venting to ensure exhaust is leaving your home safely. They ensure the complex gas and combustion elements of your system are genuinely 100% safe to run. Which brings us to the end of our explainer today, and leaves me with a pretty important question for you to ponder. When was the last time you checked your furnace filter or scheduled seasonal maintenance? Because honestly, most of the cold air panics we covered today are entirely preventable with just a little bit of routine care. Don't wait for your house to turn into an icebox to find out your system needs a fresh filter or a sensor cleaning. Take a look at your system today, stay proactive, and above all, stay warm out there. Thanks so much for joining me.